Hi students, today we are going to continue learning about chemistry. Last time we met, we learned about valence electrons and the structure of an atom. Today we're going to go deeper into how those electrons interact, and we're going to be learning about bonding. So as a reminder, let's review. What is a chemical bond? A chemical bond is a force that connects two atoms together by gaining, losing, or sharing electrons. These pictures all show a water molecule. Water molecules are when one oxygen atom and two hydrogen atoms kind of come together and are bonded through chemical bonds. And if you look closely, this is a bond here. They are bonded together because hydrogen and oxygen share electrons. Now, there are actually three types of different bonds that can form. We call them ionic, covalent, and metallic. Today we're going to really focus on the first two, and I'll briefly mention metallic. So let's talk about what an ionic bond is. This is a chemical bond that forms between a positively charged atom and a negatively charged atom. These charged atoms are called ions. That is a huge vocabulary word. Now in this cartoon you can see here we have Na, which is a sodium atom, and Cl, which is chlorine. And Na is gonna give an electron to Cl because Cl would like more electrons. And when Na gives an electron to Cl, it forms a ionic bond. We're going to talk about why these things happen and how these charges form in the next few slides. So first let's talk about how you form an atom with a positive or negative charge. So a normal atom has no charge, because the number of protons, or the positive charges in the nucleus, are equal to the number of electrons or the negative charges in the electron cloud. And the charges kind of cancel each other. So in this picture you can see there's zero overall charge in this Na atom, or sodium atom, because there's 11 protons, 11 electrons, positive and negative cancel each other. However, sometimes atoms will give away its electrons. So you see here in the valence shell right here, the outer shell, there's one electron that is kind of floating around in the Na atom, and that when that Na atom will donate that electron to another atom, it's going to be left with only 10 electrons and 11 protons, and that leads to an overall positive one charge because it's missing one electron. Here's another example. So in a Cl atom, or chlorine, we have 17 protons in the center and 17 electrons in the electron cloud, and that makes it a neutral or no charged atom. However, you can see Cl actually has 7 electrons in its valence shell, and it needs just one more to complete its electron shell to be more stable. And so what happens is a lot of times chlorine will gain an electron, it will receive one, and it'll fill that empty space. And because it now has 18 electrons and only 17 protons, it has one more negative charge. So this is actually going to be an overall -1 charge. And so depending on how many electrons it gains or loses, an atom can be positive or negative. So we call these ions. So don't forget that word. That's a really important word. Okay, now why do some atoms get a positive charge while others get a negative charge? So you might have noticed in the example right here, Na became +1, but Cl became -1. So how do atoms know whether to gain or lose electrons? Well, there's a pattern. Remember that all atoms want to get a full electron shell on the outside, in the valence shell, right? It has a certain number of valence electrons, and it wants to gain or complete its set. Now, sometimes atoms will gain electrons when it's easier for them to become a full set by doing so. For example, oxygen here has 1, 2, 3, 4, 5, 6 valence electrons, and it wants 8 to be stable, right? So it will gain 2. It's much easier to gain 2 electrons to make it 8 than to lose all 6 electrons and to get rid of and just be left with 2. It's more likely to just gain 2. It's easier. So oxygen will almost always be a negative ion. On the other hand, positive ions form when it's easier to lose electrons than to gain them to get the full electron shell. So for example, here's sodium. Sodium's a metal. There's only one electron in its valence shell. Now, to be stable, it would need 7 more electrons. Well, it's much easier to just get rid of this electron and donate it to another atom than to gain 7 more electrons. So that's what a sodium does. It just gets rid of this electron and it becomes a positively charged ion because it lost an electron. So you can see, depending on how many valence electrons there are in an atom, it will either become positive or negative. And in general, metals are more likely to become positive and non-metals are more likely to become negative. Okay, now let's figure out, how do you know what charge it is? So it's really easy. It's easy math. So all you have to do is to figure out how many electrons are being gained or lost. And that's the number charge it's going to be. So for example, in the aluminum atom, it has 13 protons, 13 electrons, and its valence shell, it's really hard to see, but it has 1, 2, 3 electrons. Now, it needs 8 to be stable. It's much easier to lose those 3 electrons than to gain 5. So it's going to go ahead and get rid of those 3 electrons. And because it lost 3 electrons, there's 13 protons and only 10 electrons, and it's going to be an overall positive 3 charge. So then to write this, you would put the chemical symbol of aluminum, which is Al, and put a +3 in the upper right-hand corner and this symbolizes aluminum with a positive 3 charge. It lost 3 electrons. Here's another example with the nitrogen atom. Nitrogen has 7 protons and 7 electrons when it's not ionized or it's a normal atom. But notice how to complete its valence shell, it needs 3 more electrons, right? So it wants to gain 3 electrons rather than lose 1, 2, 3, 4, 5 electrons. So that's what it's going to do. It's going to get 3 electrons. And when it gains 3 electrons here, it's going to have 3 more electrons than it used to. So it's going to be an overall negative charge because there's only 7 protons and 10 electrons. So there's a -3 charge. And see how I did the math there? Because there's 3 more electrons. So then you would write N for nitrogen, which is the chemical symbol, and you use the periodic table to get the symbol. And in the upper right-hand corner, you put -3 because it has an overall negative charge with 3 extra electrons. So this is how you would write and determine the charge of an atom that has gained or lost an electron. Okay, so now let's put this together. So we just talked about ions forming, and you know how ions form. So when 2 ions form and one atom becomes a positive and a different atom becomes a negative, remember positive and negative attract each other. So when those 2 atoms that are different charges come together, they form what's called an ionic bond. And the ionic bond holds these positive and negative atoms together. And when many of these atoms come together, we form what's called an ionic compound. And this is a picture of an ionic compound where it's made out of many positive and negatively charged ions. Now, ionic compounds are not molecules, so please don't get them mixed up. We'll talk about what molecules are in a minute, but ionic compounds are made out of ions, whereas molecules are different. They are not made out of ions. And ionic compounds often form what we call a crystalline structure or crystal-like structure. They usually are geometric in shape. And because they are made out of positive and negative ions, they are easily able to break down and dissolve in water. And that's another property of ionic compounds. Okay, now let's talk about covalent bonds. So we just talked about ionic, now we're talking about covalent bonds. And covalent bonds are a different type of chemical bond, and it's when two or more atoms come together and stay together because they share electrons. So remember, ionic bonds came together because of the positive and negative charges, but in covalent bonds, there's no positive or negative charges. They're both neutral, but they come together because they're trying to share electrons with each other to be more stable. And usually, when you see structures like this, and I'm sure you've seen molecules and diagrams that look like this line represents a covalent bond. Okay, so why do some atoms form covalent bonds? Well, covalent bonds usually form between atoms that are less likely to form ions or less likely to gain or lose electrons. Remember that ions are more likely to form in atoms where it's easy for them to do so. Like, for example, in the sodium atom, to be stable, it's just easy to get rid of that electron to become stable with 8 electrons in its outer shell, or with oxygen, it's easy to just gain 2 electrons to become stable, right? Well, some atoms don't necessarily have that tendency. Like, for example, look at carbon. Carbon has 1, 2, 3, 4 electrons in its valence shell, and it wants 8 to be stable. But since there's 4, which is half of 8, it's not, it's not really likely to get rid of all 4 electrons, and it's not really likely to just gain 4 electrons to become a charged particle. So instead of gaining or losing electrons, carbon is just going to share electrons with other atoms in order to fill its outer valence shell to get all 8 electrons. And that's why carbon, you will very rarely find carbon ions. It's a carbon atom with 4 bonds, okay? And so you can see here the reason why there's a C. C represents carbon, and you have 4 lines sticking out is because it's forming bonds with 4 atoms so it can get 8 electrons in its valence shell. And so carbon will usually be found with 4 bonds, and sharing electrons to gain those 8 electrons. Now, covalent bonds form molecules. So remember, this is different from ionic compounds, where ionic compounds are made from charged particles. Molecules are made from neutral molecules, or from neutral atoms, or atoms with no charges. So all of these structures you see here are made between atoms with no charge. Diatomic molecules, di means 2 and atomic means atom. Diatomic molecules are made out of 2 atoms that are the same element, and they're bonded through covalent bonds. So these are all examples, like iodine, bromine, chlorine, fluorine, oxygen. There's 2 of every single atom, and they're bonded together covalently. We call these diatomic molecules. And polymers are molecules that are complicated with long chains and a lot of atoms and have many covalent bonds. And remember, we talked about polymers for a bioplastic lab. Starch is a polymer. It's made out of many carbon and hydrogen atoms that are bonded together in these complex structures. And polymers are found everywhere in nature as well as in plastic. So polymers are a really significant part of our world today. Now let's shift gears and talk about the last form of bonding, which is metallic bonding. Now, metallic bonding, as you can tell from the name, are only found in metals, and they form when metal ions that are the same metal line up with each other closely. They get packed together closely, and when they do come together, their valence shells kind of overlap against each other. And because they're the same metal atom in the ion, what happens is it starts kind of, the electrons in their valence shells start moving freely. So they jump from one atom to another, and they're able to kind of move around quickly through the sheet of metal ions. And this picture shows you, pretend these small particles are kind of moving through these metal ions that are the same metals. This picture shows you how free moving electrons are kind of going through the crevices of all these metal ions. And this is one of the reasons why metals conduct electricity so well, is that electricity can flow when electrons can flow. And because metals, they have a tendency to bond together by letting their electrons move about freely, they will conduct electricity very quickly and efficiently. And that's very unique to the metals only. You won't find that in other atoms.